so this is a conceptual understanding question. Find the number of combinations, and note it says the word combinations. And down here you can kind of see what the difference between a combination and a permutation is. A permutation is very particular about order. A permutation thinks that archery, canoeing, and sailing is different than canoeing, archery, and sailing. So permutations always have more going on. There's always more outcomes with a permutation than there is with a combination. Always. So if we approach this from the idea of either a permutation or the fundamental counting rule, we're not going to get the right answer. So if we try to use combinations, or sorry, if we use permutations, three activities out of what, 10? 3, 6, 8, 10. We would say 10 pick 3, which is going to be 10 factorial over 10 minus 3 factorial, which is a big stinking number, okay? But this is not a permutation. And what we need to do is we need to adjust the formula just a little bit to come up with a combination. So anyways, let's use this as an example. If I did a permutation here, this is how many ways can I rearrange three things, 3 of 3. This right here is 3 pick 3, which would be 3 factorial over, that's a bad looking factorial, over 3 minus, I put that factorial in the wrong spot, 3 factorial, which is 3 times 2 times 1 over 0 factorial. And remember, 0 factorial is defined to be 1, so we get 6. But in a combination, it's just the elements A, B, and C where order doesn't matter. So how do I adjust a formula to make this work? Well, it's actually not that hard to do. I need to basically divide it by 6. So the combination formula would introduce down in the bottom a 3 factorial. Kind of weird how that is. And we would have 6 up top and 6 in the bottom, we get 1. So what we've actually come up with here is n choose r is going to be n factorial over r factorial n minus r factorial. That's the combination formula, and that generates the required number of results of combinations. And these are kind of weird concepts, I think. The numbers just get so large, it's kind of hard to comprehend. But anyways, now that I've understood, now that I kind of have a difference here, let's go over 2 questions about Marisol. Marisol wants to know how many different ways he can take 3 of 10 activities. He is worried about order. That means I'm worried about a permutation, okay? And then this one is directly related to the previous slide. Marisol wants to know how many different ways he can take 3 of 10 activities. He is not worried about order. This would be a combination. I'm going to go ahead and do the combination one first. And I wish I could say that this is as hard as it gets in this particular section notes, but it's not. So there's your combination formula. NCR is n factorial over n minus r factorial, And I think I wrote it the other way around on a previous slide to do the same thing. So anyways, let's do the combination first. This would be r, the number you choose, and this would be n. So we have 10 factorial over 10 minus 3 factorial, 3 factorial. And that was 10 choose 3. And I really don't want to write this all out, but I'm going to. All right, 10 minus 3 is 7. also have r factorial, and r was 3. And I'm going to start throwing some stuff away. This 7 all the way to 1 gets thrown out of the top and the bottom. And I'm left with 10 times 9 times 8, which is 720, over 3 times 2 times 1, which is 6, and I get 120. Now, you'll notice down at the bottom it says most scientific and graphing calculators can calculate permutations and combinations, and they can. This notation is incredibly outdated that they're mentioning. I don't even know why they're mentioning it. That hasn't been used in 30 some odd years. So anyways, you just go to math. If it's a combination, you should type in the number first. You don't have to. You can actually just go straight to math, scroll on over to probability, and choose NCR. And it will give you a place to put in n. And this was 10, choose 3. 120. Now up top, that is a permutation. And you're seeing me kind of do these things by hand because I want you to actually remember the formula for a permutation. So this is 10, pick 3, and order does matter. Because order matters, you're going to have a much, much bigger number. And the formula is way different too. It's going to be 10 factorial over, and that's the formula, by the way. I should probably write that down. The formula is n factorial over n minus r factorial over 10 minus 3 factorial. So on this one, what's going to happen as we write it all out, and I know this is time consuming and it's just too much work for your poor little butts. I get it. 10 minus 3 is 7. Everybody wants everything to just be easy. I mean, everybody wants things to be easy. And nothing in this life is supposed to be easy. If it was easy, it probably wasn't worth doing. But you get all that stuff that disappears, and you're left with 10 times 9, which is 90. I know 9 times 8 is 72, so I'm going to add a 0. And I'm going to have 720. There will always be a higher number with permutations than combinations, and get that in your head. Order is very important to a permutation. It's not important to a combination. I cannot stress that enough. All right, how many ways can a camper choose 5 activities from the 10 available classes at the summer camp if order matters? And again, you'll notice that I'm doing this, I'm writing permutation. You should probably write that too. So this is going to be 10, pick 5. R and N. 10, pick 5. And if it's permutation, we're going to follow the formula n factorial over n minus r factorial. So we're going to have 10 factorial over 10 minus 5 all factorial. And what you're going to be left with is 10 times 9 times 8 times 7 times 6. Because here's going to be a 5 times a 4 times a 3 times a 2 times a 1. So understand this, and this is a very big thing, that permutations are the fundamental counting principle. They are the same thing. Because if I approach this from the fundamental counting principle, I would say I have 10 choices. Okay, that one's taken. Then I have 9 choices. Now I have 8 choices. Now I have 7 choices. Now I have 6. So permutations are the fundamental counting principle, which is m by n by p ways, okay? And then we crank out a little math here. It's going to get on up there. What's this? This is 720. I've done that a couple times. 5,040, right? 5,040. 30,240. Now, here we say order does not matter. And again, you should probably write little things like this down. Order does not matter. Combination. That's what she is. She is a combination. So NCR, again, the formula for NCR is n factorial over n minus r factorial And why not just write it all out? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all sitting pretty over. If we do 10 minus 5, we get a 5. 5 factorial is 5 times 4 times 3 times 2 times 1. And there would be a 5 here because this is r. Times 5 times 4 times 3 times 2 times 1. And I get to throw away one of these little groupings. Just thought I changed to red there. That one's gone. And what do I have left up top? I've got my 30,240 up top. And down low, I've got 20, 60, 120. So then I have to divide that out. Zeros would cancel. For the life of me, I'm too tired for that. I don't know what's up with me. $2.52. And again, you could have just pressed buttons, okay? I'm trying to get you to get the formulas down. What do we have here? Use permutations and combinations to find probabilities. Okay, so the teacher chooses 5 students at random from the names shown to work together on a group project. What is the probability that the 5 students' names begin with a consonant? So a consonant is anything that's not a vowel, right? Not a vowel. And you're expected to know your vowels. What is it? It's A, E, I, O, U, and sometimes Y. Okay. I want to know the probability that the 5 student names begin with a consonant. So, I've already kind of laid it out here. The total of number of ways we can group 5 of 18 students whose names have consonants, because it's been counted, okay? Consonant, 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 that's 3. Consonant, consonant, that's 5. Consonant, 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 that's 8. Consonant is 9. Consonant is 10. Consonant is 12. Consonant is 13, 14, 15. I think there's more to this. Is this the full list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Something's missing here. Okay. That should be a 14. I only counted 14 names with consonants. But are there 18 students? There's 6. Okay, so it's going to be the total of number of ways we can group 5 of 14 students whose names have consonants divided by the total number of ways we can group 5 of 18 students. Now, order doesn't matter. All that matters is that these kids all have consonants, okay? So these are combination problems. The numerator of this thing is going to be 14, choose 5, and the denominator is going to be 18, choose 5. Because probability is the number of desired outcomes over the total number of outcomes. And I told you, this is where it gets kind of tricky. We have to understand probability. And it's going to be rough on some kids. Now, I'm not going to spend my life writing this one out. So go to Math, Probability, NCR. We got a 14, choose 5 in the numerator. That's going to be 2002. And in the denominator, what do we have? Whoops. Pressed the wrong thing. I'm just going to highlight the old one. We have an 18, choose 5. 8,568. So let's see what this works out to be. 2002 divided by 8,568 is roughly 0.2337. If you're a fraction kind of guy, I am. But with big fractions, they don't make as much sense now, do they? It's 143 over 612. You know, fractions don't start making a whole lot of sense to the average person after they get past the denominator of about 10. After that, it's kind of a hogwash thing. All right, here's something old. How many different words, and of course you've never seen it, I say it's old. How many different words, real or imaginary, can be formed using all the letters in the word rearrange? And the process is 5 different tasks. First, you're going to choose a position for the 3 R's. And then you're going to choose a position for the 2 A's. Then you're going to choose the positions for the 2 E's. Then you're going to choose the position for the 1 N. And you're going to choose the position for the 1 G. And I would love to spend 5 minutes of your life showing you how this formula came to be. But here it is. It's n factorial over n1 factorial, n2 factorial, and so forth. Now, these are the repetitions of a letter. Like, there's 3 R's, there'd be a 3 factorial. There's 2 A's, there'd be a 2 factorial. There's 2 E's, there'd be another 2 factorial. And then you have a 1 factorial and another 1 factorial for the N's and the G's. Now, the word rearrange has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in it, right? 4, 9. So it's going to be 9 factorial over 3 factorial, 2 factorial. That was for the R's. 2 factorial. And these guys are kind of optional. Like, they really are. Why are they optional? Because 1 factorial is 1, just like 0 factorial is 1. So those are kind of optional. All right. I'm not going to write it all out here. Go over where the factorial key is. 9, math, probability, factorial. I probably should have gone and used the answer frac thing. But anyways, let's go to math, num, n over d, and do it the proper way. We'll put a 9 factorial in the numerator. And we'll put the rest of it in the denominator. I feel like there ought to be a shortcut to factorial on the keypad, but I don't think there is. I have never spent any time of my life looking for it. Probably won't. And I'm not going to put in the 1 factorials because 1 factorial is just 1. If you understand math, you know you don't need it. So there's 15,120 ways to rearrange the letters and create new real or imaginary words from the word rearrange. Kind of interesting little problem. And now we're at the you tries here. And I'm leaving that entirely for you. And you should try this. You should try. But a lot of you won't, because I don't know. Couldn't tell you.